I drink water, it's refreshing. I drink water, makes my bones strong. I drink water. Delicious. I drink water because my water bottle is green. How many ounces did I drink? I have 24 ounces left to go. Can you see that? People, if I drink, here's your test, 32 ounces, and I have 24 ounces left. How many ounces did I drink? 8. Okay, we're going to do the chapter 5 quiz review. All right, here we go. Because I haven't recorded it in the past, I'm recording it now. Let's see, the camera is like, I got to stand back here for the camera to see me, not that you care. But, yes, Louis, what's your question?
Oh my God, Louis is famous now.
He will be when you get a million hits on this. Probably like 100,000 hits. Like your Instagram. All right, here we go. Number 1, look at, that's all that from me touching at the back. Here we go. Number 1, 18e to the 7th, 3e to the 10th. 18 divided by 3 is 6, and then 10 take away 7 is 3. Now I'm going to have 3 in the denominator, so I can write it like that. Or, if you're like one of these people, you could write it as 6, 7 take away 10, e to the negative 3. Now, this, I am going to raise this to the 4th and this to the 4th. What is 2 to the 4th power? So another way I could write this is 2 to the 4th and e 3x to the 4th, right? You can just distribute the 4 to both of this. So it's 16 e. Now remember, we multiply these, 12 to the x. E to the 12x, I should say. So big, well, it depends on what number you plug in for x. Yeah, Samurai Jack. Unit 5, quiz review. Quiz? It's a quiz. We can't retake this because time is running out. And next week is finals. Congratulations. You're halfway done with Math 3 Honors on Friday next week. You're not halfway done with your life. Okay. All right. Determine if the function is increasing or decreasing. Explain how you know. Well, as long as the exponent is positive, and this is a number bigger than 1, it will increase. Positive. Is e bigger than 1?
Yeah.
2.72 approximately, 2.71. So this is increasing. This is also increasing because this is bigger than 1, and that's positive. So therefore, increasing, positive exponents. Now, if this base was a fraction, that'd be a different story. So, let's move on, shall we? No, that looks dumb.
No, it doesn't.
It does.
It's really funny. This is fun.
What's that? You want a piece of me? You want? Oh, you thought you could hit me there. Oh, I blocked it. Oh, I blocked it. Oh, you want a piece of me? Want a piece of me? Come on, right here. I'm right here. I'm not afraid. Oh yeah. Oh. There. Huh? I did. It's at 5 minutes and 15 seconds.
See, that's really short. You did good.
Oh, graph the logarithm. Oh shoot! It didn't have what I wanted it to have. Hang on. What are the? What are the 3 easy logs that make it easy to graph? Yes, Nathan. Famous.
Log, base, whatever, 0.
Okay, first we want x equal to 0. What's another one?
1.
1.
And then I guess 4.
4. Whatever the base is, we list that as 4. Do you guys remember that? So, what is log 4 to the 0 power equal to?
Not solution.
No solution. Now, there's a couple ways we can see this. We can write this in exponential form. We can say 4 equals flip. What do I plug in for y to make it equal to 0? Nothing. You can't make it 0, right? The logarithm is multiply 4 by itself over and over again, but it'll never be 0. So this is, and you can also do the change of base. Log 0 over log 4. It'll say error. Or what my calculator says, because it's cool, it says foo. F-O-O. No solution. Okay. Log base 1, log base 4 to the 1. What does that equal? Let's write an exponential form, shall we? 4 equals, flip it. What does y need to equal in order for it to be 1? 0. Anything to the power 0 is 1. And it will always be, the 0 will always be no solution, 1 will always be 0. And now let's do log base 4, 4. That'll be 1. 4, y, 4. Y needs to be 1, and there it is, 1. Well, what would be easy? I mean, for 4, you probably want to put 16, right? But this is all we need. Okay, let's put in our things. 1, 2, 3, 4, 5. Make sure you label it on the test. 1, 2, 3, 4, 5. Label it on the test. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And let's do the 0. No solution, x equals 0, will be my asymptote. So you draw a line right there. You must draw that dotted line. Yes, absolutely. I will take points off if you do not. If you do not. 1, 0 is there. And 1, 2, 3, 4, 1. Those are my points. Remember, the asymptote you hug without touching as best you can. Hit the 2 points, and then you flatten out. And there's your logarithmic function. Label it f of x. Do you think you can do that on a test?
Yeah. That's simple.
If you were to practice this, change this to 5. See if you can graph log base 5 to the x. Well, you plug in 0, 1, and what did you plug in here? 5. So then you go over 5 up 1, right? Or you can change it to 7, log base 7. Practice it. Relatively the same, except this number is the only one that's going to change. These will be the same.
I just want to make sure because sometimes tests do this. They're going to be like a figure possible and have to get negative.
Where?
I don't know.
You can't have a negative in the base. So no. N-O spells no. Do, 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 do. Do, 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 do. Okay, graph g of x equals e to the x power. You can use your calculator for this, or we can say e equals a number. What does e equal? E is approximately 2. I'm going to say 2. I normally said 2.71. I'm going to say 2.72 because that's going to round it up. So if we're going to graph this, let's plug in 5 x's. Negative 2, negative 1, 0, 1, and 2. Because we need some sort of x. And I figured 2 negatives and 2 positives would be great. You could put negative 3, negative 2, negative 1, 1, 2, 3. You know what I mean? But see how this is kind of like in the middle? Anyhow, let's say g of x equals 2.72 to the x instead of e. You can do that, or you can just punch in your calculator the e button, right? So in your calculator, I'm going to do, see the natural log? Second e, and I'm going to do negative 2. Boom. And I get 0.135. Second e, negative 1. 0.37. Fine. What's e to the 0? 1. What's e to the 1? 2.72, right? Second e to the 2. 7.39. Let's put our labels. 1, 2, 3, 4, 5. So make sure you get those at 1, 2, 3, 4. Make sure you can enter those in your calculator. Make sure you're skilled for your calculator. Okay, now we'll just plot the points. Okay, negative 2. It's a very small number. Negative 2. I got a point right about there, right? Negative 1. 0.37, very small. Get close to 0 right there. 0, 1, right there. 1, 2.72. I shoot up there. And then 1, 2, 1, 2, 3, 4, 5, 6, 7.39, right about there. Now, this is an asymptote. It will not cross it, so you hug that line and you shoot up. It's an exponential function. That's what those look like. Label it g of x. It cannot cross the y-axis because I can never make this negative. I can't put a number in here to make that negative, so will not cross the x-axis. Sorry, the x-axis. X! Wah! Probably about 7%. Yeah. I look happy on the outside, but my heart. I look happy on the outside, but my heart is dark and gray. Kind of like the clouds. If you could see what my heart would be, do I look sad?
No.
Oh, heart. That's really cringy. I'm gonna see this video and go, he's so cringy. It's like the cringiest freaking loser teacher ever. Okay, all right. Write an exponential form. Write that in exponential. All right. So, in order to write this in exponential form, what's my base? 2. 2. I put my equals, and then I flip it. 8 to the 256.
That's so true. That makes sense.
Is 2 times 2 to, how can you check your answer, right? Hit 2 to the 8th, you should get 256 on your calculator. You can check it. But I'm going to move on. Now, write this in logarithmic form. So, what's my base for this? 5. So I'm going to write in log form. Where's my base for log? Base 5. Make sure you write the 5 smaller and lower, right? I'm going to put my equals over here because I need some space. Flip it. Yes. 0.008. Flip it. -3.
Is that true? That doesn't equal that?
Go on your calculator and write 5 to the -3rd. You get 0.008. Or we can do the change of base and go log 0.008 over log 5. Anyhow, it doesn't matter because, I mean, you check that, and then that should work. You have to check that on your calculator to make sure that works. -3. Does it? I don't know if anyone checked. I want to move on. Foo. Should I not say that? You saw a gang? Okay. Evaluate the logarithm. Basically what this is saying is, what does log 3 to the 243 equal? So, on your calculator, you got to use your change of base. So, what I would do, I'm going to do natural log, because I've been doing log for change of base. You can do log if you want. It's just a different button. Natural log 243 divided by natural log 3. And that should give me my answer. Right? If you do log 243 or log 3, you'll get the same answer. It's just a different base. Natural log 243 divided by natural log 3. And I get, what'd you guys get? I got, did you guys get 5? That's all you've got to do. So when it says evaluate, it means solve. When I ask you to evaluate, it means solve. Next question. Okay, use the properties of logarithms to expand. Remember, we have the product property, the quotient property, and the power property, right? So you're going to use those. Remember, the product property means, well, product property is multiplication. The quotient property is with division. What does this fraction bar mean? Division. And I also have 2x is a multiplicationer. So let's do it one at a time. Using the quotient property, log 3 over 3 divided by 2x is log 3, 3. Add or subtract? Subtract log 3, 2x. But wait. Sorry. Let me try that again. But wait. There's more. This is multiplication. Think, think. Log 3, 3 minus log 3, 2 plus what? Log 3 what? X. Yes.
Is there gonna be anything like how remember that time when we got like a 3 in front of the log and we rewrote it as 12 and we
That's a power rule, maybe. But wait, there's more. What is log 3 to the 3 equal to? Log base 3, 3. 1. When the base and the answer are the same, right, we can write this as log 3, 3, base 3, switch it. You can see that this is equal to 1 minus log 3, 2 plus log 3x. And that, my friends, is the final answer. Yes.
can we simplify even more? Like we turn the log base 3 into its like actual number, subtract it from there, then leave it as something.
Well, we want to leave it as in log form when we expand, because we're just expanding when we're asked to expand. And if I ask you to expand, I will also, right, there it is, 1 minus log 3, 2 plus log 3x. I will also, oh, I guess that's it. I was going to ask you to compress, but maybe, yeah, there will be a compressing one. But for now, this next problem, sorry, I jumped ahead of myself. Solve for x. Solve for x. Thank you. In order to solve this, let's put it in log form first, right? So, log, what's my base? 15. Make sure it's little and small, right? Little and low. Equals. Switch it, 11x. What should I use? Natural log or log base 10?
10.
I heard 10. Log 11 divided by log 15 equals log 11 divided by log 15, do 0.885. Now, how can I check my work? back into original equation. So you do 15 raised to the 0.885 power, and I should get 11, right? Plug it in your calculator, and you will. Yes.
I don't know what I did wrong.
This is the hard one you've been asking for. Are you guys ready? Okay, unpause. All right, solve for x. Identify the extraneous solution. So that means one of these answers is not correct. Now, like Nathan said, I noticed that we have the same base. So I can use the product property, and instead of expanding, I can put them together. Shall I log 6 3x times x minus 1 equals 3. Right? Using the product property, instead of log 6 3x plus log 6 x minus 1, I can just do 1 log 6 and then multiply those together, right? That's what the product property tells me. But I'm asked to solve this. So in order to solve this, I want to get rid of this log base 3. Big 6, right? I want to make this the exponent. So now I make big 6 the base. It's not really big, it's just like regular, but now this is an exponent. And then I need to make whatever I do in the left, I got to do in the right. If I have a base and log base 6, both have a base of 6, what are those? Starts with an I and rhymes with binverse. They're inverses. You guys are so smart, right? Because they're inverses, they cancel out. And what's left over on this side? 3x times x minus 1, right? Because that's what's over there. Equals what? This side, 6 to the 3rd power. 216. So let's rewrite it, shall we? Let's go scroll. 3x times x minus 1 equals 216. Let me rewrite that because it came out weird. 3x times x minus 1 equals 216. So now I got to get rid of the parentheses through multiplication. So I multiply this out and multiply this out. 3x squared, 3x times 1 minus 3x equals 216. How are we doing? Should I pause so you guys can talk about it with each other? Okay, I'm pausing. Extraneous solution. Let's recap what we just did. In order to solve this, let's clean it up. Because I have the same base, I can bring these together, 3x times x minus 1. In order to solve it, it'd be nice to get rid of the logarithm if I can. So I did a log inverse by making it a base of 6, and we are now at, I multiplied this out, and I notice when I have an x squared, what do we call that? Starts with a C and rhymes with quadratic.
No, it doesn't. That's not really that.
What does it start with?
Q.
Q. Quadratic, right? Whenever I solve a quadratic, what do I need to do? Set it equal to 0. I have the 216 on the right, subtract 216, right? Then we can do like the Xbox parentheses or whatever, or the diamond or whatever. So it'll be 3x squared minus 3x minus 216 equals 0. But ultimately, I can factor it out to solve it, right?
Yeah.
Pause it.
No, I was just asking.
I did unpause it. So, quadratics, in order to solve it, it starts with an F and rhymes with tractor. No one's
Factor.
not fractor, but factor. Fractor's more fun than factor? I never thought of it that way. That's a good point. So, because of this, I need an X box parentheses. However, I see a 3 here. I see a 3 here. I'm wondering if this is divisible by 3. So I can find the greatest common factor.
That's genius.
I would say I'm genius, but I've done this many times, so kind of not really. 72, if I factor out a 3. Now, I can just do the x, negative 72 over negative 1, right? To factor that out, stick out. Pew, pew, pew. What times what equals negative 72 and adds to negative 1? 8 and negative 9. 8, negative 9. And so 3 times x plus 8 times x minus 9 equals 0. What does x equal? Negative 8 and positive 9. Do you guys remember what the original question was? Solve for x, but there's an extraneous solution. Should we do Godzilla time real quick? Here we go. If I say log 2 to the 8 equals x, what does x equal, right? 2 flip x 8. What does x equal? 3. Okay, we're doing Godzilla time, right? Does that make sense? 3. X equals 3. If I did log 3, 9, x, what does x equal for that? 3, switch. What does x equal? 2. Right? Now, let's do this. Log base 3 to the negative 9. Let's solve it, shall we? 3. Okay, what can x equal in order for that to be negative 9? I heard two answers. Let's explore the first answer I heard first was negative 2. What is 3 to the negative 2? Well, it's 1 over 3 to the positive 2, which is 1/9. Is my answer negative? No. The other answer I heard was you can't do it. Can I plug in any number here to make this negative? Because what do exponents do? It says I multiply the number by itself over and over and over again. But 3 is always positive. So my answer cannot be negative. And the rules of exponents says we also cannot put a negative here too, by the way. But this always has to be positive. Guys, get it? Make sense? Okay, Godzilla time is over. So my two answers are negative 8 and 9. X equals negative 8 or positive 9. Now, what if I plugged in negative 8 here? What's 3 times negative 8? negative 24, which makes this negative. Can this be negative?
No.
No. What if I put a negative 8 here? What's negative 8 minus 1? Negative 9, which is negative. Can this be negative? No. So guess what? Plink, plink, extraneous solution. Let's make sure 9 works. 9 minus 1? 8. Positive. 3 times 9? 27. Positive. So my answer is 9. Yes, Louis?
On the test, do you want us, like, if we reach this point,
All right, and study for the quiz,
tell them to like
which is tomorrow. Most likely, do each problem 4 times.
Tell them to like and subscribe.
Oh, please like and subscribe my YouTube channel. I'm getting more fans, so click on the bottom to make sure that you subscribe. It helps me a lot, helps me fund for getting calculators for my students, and I'm going to also get that trip to Hawaii.
You just sneak in.
I'm going to sneak in my new video. Look for my next upcoming videos called Sneakers. I'll teach you how to sneak in to different places like Disneyland. All right.